Hi guys! In this video we're going to solve acceleration problems using the guess method. Here are the equations we will use, and these should be at the top of your notes page. Remember, when solving word problems you should thoroughly read the problem, underlining key information, even labeling it if necessary. When using the guess boxes, the givens is what information you're provided with in the problem itself. The unknown is what you're going to solve the problem for. The equation is the formula that you will use to solve it. Substitution is where you're going to replace the variable with the actual value from the givens box. And then the solution is the answer. Remember, when using the guess boxes, that you need to show units in the givens and the solution box. In this first example, we accelerate from rest to a speed of 28 meters per second in 20 seconds. So that is our givens. So rest would be our VI. It's a value of 0 meters per second. Our VF will be the 28 meters per second, and then our T is 20 seconds. Alright, our unknown is we're looking for acceleration, so that is A. Looking at our formulas from the top of our notes page, we will see that the formula for acceleration is delta V over delta T. Remember, the delta means VF minus VI. So when we substitute, we would say 28 minus 0 over 20. And then when we have our answer, when we calculate that, we get 1.4 meters per second squared. Acceleration will always be squared, so make sure you're being correct with your units. Next, we've got some graphs, qualitative graphs that we are going to draw. So we see that our acceleration and our motion is positive. So and we see that there is acceleration occurring. So we've got to make sure that we have that curved line going positive. Our velocity is increasing in the positive direction, so we would show that. And then our acceleration, 1.4, is a positive number. And this is what we did in class last time. Now, as far as our distance, what distance does it travel? We're going to use the same information and include the acceleration we just calculated, which means if you did not get the calculated acceleration correct, now B is also going to be incorrect. So be careful with your math. So we had our change of V calculated from above as 28. And then we had our T as 20. And our A from calculating it in the previous problem at 1.4. Okay, our unknown now is distance. Remember, distance is at change of position. We learned that in Unit 2. Our equation then, looking at the variables that we have, will be this half times A times T squared. So substituting, setting that up, I don't really have a lot of room here to do every single step, but we can go ahead and set it up so you see what it looks like. And remember that squared is for the time only, so the next step would have been this if we had calculated it. Alright, and when we do calculate that, we get 280 meters. So that's our first example. This allows us to see acceleration and distance. Our next example is looking for time. So a car is traveling at a speed of 30 meters per second and encounters an emergency and comes to a complete stop. So hopefully you see that this was our V initial this time, and stop is our V final. Alright, and we want to know how much time it will take for the car to stop if it deaccelerates at this. So that's our acceleration, our A. So we have VI at 30 meters per second. We've got VF at 0 meters per second. And we have A at -4 meters per second squared. Now, please note that anytime you have a deacceleration occurring, the value should be negative. Sometimes it's given to you as a negative, like in this problem, but other times it will not be, and you'll just have to remember a slowing down deacceleration is a negative value. So our unknown is time. Looking at our formulas, we see that time is delta V over A. So that's VF minus VI divided by -4. So when we do that math, it's -30 divided by -4. So we end up with an answer of 7.5. Keeping in mind, because we have a negative over a negative, those cancel out and we get a positive number. In example 4, we have a cart rolling down an incline for 5 seconds, and it has an acceleration of 4 meters per second squared. The problem is asking that if the cart has a beginning speed, so here's our VI, we want to know what its final speed is. So that's our unknown. So we are given time at 5 seconds. We're giving acceleration at 4 meters per second squared, and we are giving VI at 2 meters per second. Again, our unknown is VF. That's what we don't know. The formula for VF we can get straight from the top of our notes. It's VI plus A times T. So we have 2 plus 4 times 5. We simplify that a little, we get that, and then when we do the actual final math, we get 22 meters per second. We're looking for a speed, so our unit should be in meters per second. In our fifth example, we have Susan's car accelerating at a rate of 3.6 meters per second squared, and after 6 seconds she was at a speed of 92 meters per second. We want to know the initial speed this time. So we have acceleration at 3.6 meters per second squared. We have time at 6 seconds, and we have final velocity at 92 meters per second. Our unknown is VI. The equation for that is VF minus AT. So we have 92 minus 3.6 times 6, or 92 minus 21.6 if we work through that a little bit, giving us an answer of 70.4 and meters per second because it's speed. In our final example, we have a mountain goat that starts a rock slide and the rocks crash down the smooth slope. The rocks are traveling 100 meters along the slope, and if they reach the bottom in 5 seconds, we want to know what their acceleration is. So we're looking for acceleration again. But this time, what I have is delta x. I have 100 meters. And I do have t at 5 seconds. Now, I have VI. It doesn't really tell you in the problem directly, but the rocks started at the top of the slope with 0 speed. So our initial speed, or initial velocity, is 0. Okay, our formula, then, because we have x, we have to look at all of the variables that we have in our givens and decide which formula is the best one to solve for acceleration. And we hopefully arrive at this one. That's a T, by the way. It's just really hard to use this stylus. I'm not used to this. So hopefully as I continue to do these videos that they get a little prettier. Alright, so now substituting in the actual values for the variables. We have 100 minus 0 times 5 over 0.5 times 5 squared. So simplifying that, we get 100 over 0.5 times 25, or 100 over 12.5. So when we do the final math, that was a point there, when we do the final math, it comes out to 8 meters per second, and we got to square it since it's acceleration. So there you have it. There should be one example for each of the question types that are on your next couple of worksheets. Be sure to rewatch this if you need to. Thanks.